Good morning, everyone. So what we're going to be working with today is something that you've never heard of, but it's going to continue working with binary code, is something that's called parity bits. A parity bit. Which again, it doesn't make any sense to you at the moment, most likely, because you've probably never heard of it. So what a parity bit is, I'll explain it this way with an example first. Let's say I have this, right? This string of binary code. And what we did last week was that we analyzed that binary codes were just literally sequences of zeros and ones to represent everything. It's a computer language, represents words, represents numbers, and we worked with analyzing what numbers that would represent, right? Which you guys actually did an amazing job, which I'm happy to see. What a parity bit is, it's a number that we usually have, right? And when you hear the bit just means one of the numbers, one of the digits. Sometimes you'll see it at the end, sometimes you'll see it at the beginning. We'll go with working at the end, right? We call that a parity bit, right? That number at the end. And what a parity bit does, a parity bit actually is a number that's used to actually be able to see whether any mistakes were happening or happened when a computer sent information from one computer to another, right? So imagine having two computers, right? A computer that's sending information and a computer, imagine having this, right? A computer that's sending information, we'll call that one, right? And computer two, which is the computer that's getting that information. So it's like you typing at this computer and then sending it to your friend at the other computer, right? What a parity bit does, it's a number that's actually used to be able to see whether the information that went from this computer to that one, whether there were any mistakes, whether there were any errors, right? Because again, that's going to be able to tell us whether this information here was sent correctly to that one. So all a parity bit does, it's just a way to be able to see whether there were any mistakes, any errors with the information that was sent. The way that that works, and I'm going to show you then, because first I got to go into something else, but the one thing I did want you guys to understand first and foremost, even though it doesn't probably make any sense yet, a parity bit is just a number in a sequence of binary code that's there to be able to show us whether any mistakes happen from one computer to another, right? Now let me show you the different sequences that we have, right? And I'll go back to parity bits to show you because I need to show you certain things first. So when it comes to parity bits and analyzing them, we first need to analyze two different sequences. We have something that's called an even sequence, right? And then we have something that's called an odd sequence. And I wonder if some of you would probably be able to figure this out on your own. I'm going to show you what they are, and then maybe you guys can see it. An even sequence, for example, would be something like this. That would be an even sequence. An odd sequence would end up being something like this. Let me put another zero. So this one's an even sequence, this one's an odd sequence. The way that we actually tell the difference between one and the other, in even sequence, all you ever care about, just like when we're actually trying to calculate values, you care about the ones. The ones represents information that we have. The zeros means we just don't have it, right? So we look at the ones, and when we look at the ones, we see this one has 1, 2, 3, 4, 5, 6, right? We have 1, 2, 3, 4, 5, 6 ones, right? We have 6 ones. The odd sequence, we have 1, 2, 3. We have 3 ones. That's why this one is an even sequence. That's why this one's an odd sequence. An even sequence is always going to have an even number of ones, right? So an even sequence is going to have like 2 ones, 4 ones, 6 ones, 8 ones, right? An odd number sequence is going to have an odd number of ones. So it have like 1, 3 ones, 5 ones, 7 ones, all of that. If the amount of ones is if the amount of ones is even, it's an even sequence. If the amount of ones is odd, it's an odd sequence. That's all it is. Again, it's just analyzing the ones. Just always remember odd numbers and even numbers, and we're counting the numbers of ones that are here, right? the way that this actually helps now, because again, I wanted to go into showing you how the information helps, how computers can actually use this to see whether they're writing mistakes or not, right? The way that that works is, let's say again, you have computer 1, right? You have computer 1. We know that computer 1 is sending information to computer 2, right? The way that these computers operate is they've set literally a sequence marker for each other. They know that the certain sequences is what they're sharing. So for example, they've already registered that they're going to share an even sequence, right? So let's say that this computer sends even sequences, right? Let's say that that computer gets an even sequence. If this sent an even sequence and that received an even sequence, we know that the information that was set between them is correct. Everything was good. There were no mistakes. If, for example, now, let's say that this computer 1, sent even information, even sequences, and then the second one received odd sequences, since they don't match, then we know for a fact there was already a mistake. Most likely, a mistake happened somewhere along, and again, even if the sequences are equal or the same, even if both of them are even, sometimes there can be mistakes, which I will explain that in class then. But there are times where they can be the same and still have a mistake, but most of the time, whenever the sequences match up, most likely the information is all good, right? But when they are different, it means that there was a mistake that happened with the information that went from one to the other, okay? So that's how those sequences come into play. It's to be able to show computers that they're both equal. If they're not both equal, it means that there was an error. Something went wrong. Something actually happened because they don't match. That's how they play into each other. And now again, I just want to make sure that you guys actually have a good understanding of being able to see whether the sequences are odd or even. Let's say that I gave you a sequence like this. 0, 0, 1, 1, 0, 1, 1, 0, right? 0. You see that? Again, if I want to figure out if it's odd or even, the one thing we want to focus on are the numbers of ones, right? All we care about is the ones. So we have 1, 2, 3, 4, right? We have 4 ones. Since we have 4 ones, that's an even sequence, right? All it is, guys, just always remember, count the number of ones and that will tell us what kind of sequence we have. Let's say that I had another 1 now here at the end. If that now went to 5, that would be a different sequence. If it was 5 ones, it'd be an odd. But when we have an even number of ones, it's even. When we have an odd number of ones, it's odd, right? Now, let's go back to the parity bits, right? Because again, the parity bits are there to be able to help us balance out the information. Because you're not always going to get perfect sequences like that. What happens is a digit a lot of times is added to the end of a sequence, and that's why it's called a parity bit. It's a number that's added at the end to be able to see whether there's actually going to be even or odd information shared, right? So let's say that I gave you this 0, 1, 1, 0, 0, 1, 0, and then let's call this last one x, right? What that x represents, that would represent our parity bit, right? That would represent our parity bit. That would be the number that's used to be able to see whether there's going to be a mistake sent from one computer to another. What I'm going to ask you, this whole sequence, I want to know what x is going to be for this whole sequence to be even, right? I want it to be even. I want this whole sequence to be even. So I want to know, what does x have to be for this whole sequence to be even? So again, first thing I'm going to tell you guys, we want it to be even. So first, let's start with counting the ones, right? We have 1, we have 2, and we have 3, right? We have 3 ones. Remember, 3 is odd. We want it to be even. So for it to be even, we can't have 3. We need to put an extra 1, right? So x in this case would have to end up being, let me write it in blue. X in this case would have to end up being 1, right? X would end up being 1. And the reason why x has to be 1 is because exactly that. We want it to be even. There's 3 ones here, so now if we count it, we have 1, 2, 3, 4. Since we have now 4 ones, that would make it even. That one will be called the parity bit. That's the number that's used there to be able to show what our sequence is going to be so that the information sent from computer to computer is correct. That's how you make it. And again, since it's binary code, you're just using the numbers 0s and 1s when you're substituting, right? So again, if you want to make it even, we would put a 1 there because now we would have 1, 2, 3, 4 ones, right? Let me get rid of this 3 to not confuse you guys. We would now have 4 ones. 1, 2, 3, 4, making it even. That's why we put a 1 there. Let's say that, again, I'm going to leave x there, right? Let's say that instead of it being even, I wanted it to be, let's say I want it to be odd, right? If I wanted it to be odd, it's that same idea. We got to think, right? We have 1, 2, 3, right? We have 3 ones, 3 ones. We know that the 3 is already odd. Since it's already odd, it's what we want. Since that's what we want, we know that the number we're going to put here is 0 because we already have what we want. And again, the easiest thing that I'm always going to tell you is check everything all the time. Because once you've written it, it's either a 0 or a 1. Once you've written it, it's easy to check. Once I put that number there, 1, 2, 3 ones, it's odd, I know I'm right. And again, when we already have what we want, we put a 0. Let me show you one more, guys. Same thing, right? I'm going to give you a sequence, a binary. Let's make it 1, 1, 0, 0, 1, 1, 1, 1, 0, right? I'm just putting more. So we have that, right? I want to know what x is going to be, right? I want to know what we're going to substitute for x in order to make it odd, right? First one I want to do, I want to know what it has to be for it to be odd. What am I going to substitute for x? So the same idea, guys, let's count our ones. We have 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6. We have 6 ones. Okay? We have 6 ones. We want it to be odd. 6 is even. So since 6 is even and we want it odd, well, we have to substitute for x. We're going to have to make x. We are going to have to make x a 1. Okay? And the reason that it has to be a 1, we want it to be odd. We had an even number, right? So now if we go check it, let's just check it. We have 1, 2, 3, 4, 5, 6, 7. 7 ones, 7's an odd number. It's what we wanted, right? Let's say that now we wanted the opposite. Let's say that we wanted it to be even. Right? We want it to be even. We want to figure out what x is going to be. So we have 1, 2, 3, 4, 5, 6. We have 6 ones. Since 6 is already even, we already have what we want. Since we already have what we want, we know that we don't need another 1. We're just going to end up putting a 0. Because again, we already had 6. It was even. So put a 0. We don't need anything else. Because now once you check that, you have 1, 2, 3, 4, 5, 6. 6 even. That's what a parity bit is. When the computer knows that it wants to send even information, it needs to put a number at the end, a parity bit, to be able to send even information. If, for example, a computer wanted to send odd information in odd sequence, it would need to put a certain parity bit there to make it odd, or to keep it at odd. That's what a parity bit does. It balances out what the sequence is to then be able to send it to a computer. And in the end, if it's correct, if this makes it even and then the computer that receives it is even, we know that all the information's right. If what is sent is odd and what it receives is even, we know a mistake happened. Again, those are parity bits, guys. Something that you've never worked with, never heard. Again, it's not difficult, but it's just being able to tie it all together. Any questions, guys? Feel free to ask. Take care.